Alright, so we are starting our next unit. This is Unit 8, and we're going to focus primarily on implementing what we've done in the past two units with our trig stuff, but applying it to triangles. So this unit's going to focus on triangle trig. And to kind of recap what you've done in geometry and to bring it to the pre-cal level, we're going to focus mainly on right triangles and area today. So let's go ahead and get started with that. Thinking back to your geometry days, you've definitely heard of SOHCAHTOA before. So we're going to utilize that information again. So you see here we have our 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. But for today, we're primarily going to focus on those main 3. Okay, sine, cosine, tangent. SOHCAHTOA, right? So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So we'll utilize those 3 trig functions to help us solve a right triangle. So what it means to solve a right triangle is to find all of the angle measures and all of the side lengths. That means that you've solved the triangle once you have all of that information. Now, it's not always going to give you all that information, so that's our job, is to figure out the pieces that it doesn't give us. Thinking back to geometry, some of the tools we utilized were the Pythagorean theorem, okay, a squared plus b squared equals c squared. And just a quick refresher in case you forgot, the sum of all the angles of a triangle comes out to 180. So if I add up angle A plus angle B plus angle C, should always give me 180 degrees. So starting off, we all need to label our triangles the same. So when we have a right triangle here, so there's my right angle, we're going to start with angle A, and then we're going to have B up here, and then angle C will be that right angle. Now the sides correspond to the opposite of the angle. So angle A is here. That means that side A is going to be opposite of that angle. So there's A. Here's B. So side B would be down here. And then C would be our hypotenuse. Now we're always going to use uppercase to represent the angle and lowercase to represent the side length. So let's look at some examples of what you're going to be asked to do in order to solve a right triangle. So example 1, A, it tells me that side B has a length of 2 and the angle A is 40 degrees. So let's go ahead and draw our right triangle and then label it. So here's A, and that would be 40 degrees. There's angle B, angle C is my right angle. So side B would be down here. There's 2. So let's go ahead and solve for the missing angle. That seems to always be the easiest. So I know that A is 40, C is 90, and I want to know what angle B is. All those added together have to give me 180 degrees. So that means that angle B is going to have to be 50 degrees. Alright, so I have all my angle measures now. Now we need to find our sides. So we need to find side A and side C. Now there's multiple ways you can go about using your trig functions here. You could do sine or cosine or tangent, depending on what you're trying to solve for. I'm going to solve for side A first, and I'm going to use tangent. So I'm going to use the tangent of 40 degrees. And that's going to be opposite over adjacent. So that would be A is the opposite side over the adjacent side, which is 2. So to solve for A, I'm going to multiply the 2 over. So side A is going to be 2 times the tangent of 40 degrees. And punching that into the calculator, we would get A equaling 1.7. Now, when you're using your calculator, make sure that you are in degree mode. Otherwise, it'll give you a very different answer. Now, I have two sides. You can go through and use another trig function if you want, but we also can make use of our Pythagorean theorem. Now that we have two side lengths, we can find the third. So a squared, 1.7 squared, plus b squared, so 2 squared, equals c squared. So c squared is going to equal 6.89. Square root both sides, and we get c equaling 2.6. Alright, let's look at b. b is similar. It gives me a side length and an angle. But this time it's going to give me a hypotenuse here, so I can utilize sine and cosine a little bit easier. But let's look at setting up the triangle first. So here's my right triangle. A, I don't know. B is 55 degrees. And there's angle C. So this time it gives me the hypotenuse, like I said. And I'm going to have to find side A and side B. But let's start with finding angle A. So angle A plus angle B plus angle C all have to add up to 180. So that means that angle A is 35 degrees. Now I have the hypotenuse, and I want to find B first, let's say. So that means I'm going to do sine. And I'm using this angle up here, 55 degrees. So sine of 55 degrees equals opposite over hypotenuse. So the opposite side would be B, and my hypotenuse would be 20. So again, multiply over. So B would equal 20 times the sine of 55 degrees. Punching all that into the calculator, we get B equaling 16.3. Now, if these had units, you would have to include the unit, but for these problems, you can see that there are no units, so we don't have to put inches or feet or anything like that, unless the problem states that in the beginning. Now, I have two side lengths to find the third. I'm going to use the Pythagorean theorem. So a squared plus 16.3 squared equals 20 squared. So a squared would equal 134.31. That's after squaring and then subtracting. Square rooting both sides, I would get a equals 11.6. Now, that's not the only way you can solve this problem. There's a lot of different ways you could go about doing this. Let's say you wanted to find a first, using that same 55 degrees. Instead of using sine, you could have used, and this is just an example, the cosine of 55 degrees would be adjacent over hypotenuse. So it would be a over 20. So a would equal 20 cosine of 55 degrees. And so on and so on. You could do using angle A, right? We found angle A to be 35 degrees. You could have done the cosine of 35 degrees equals B over 20, right? And done it that way. So there's more than one way to do these problems, but they'll all give you the same answers. Okay? Alright, now let's look at when it only gives us side lengths here. So these are a little bit different. So again, always start with setting up the right triangle. Okay, so there's my right triangle, A, B, C. And it tells me that side A is 3, side B is 2. I don't know what side C is. So in this case, I'm going to start with finding side C using the Pythagorean theorem. So 2 squared plus 3 squared equals C squared. C squared equals 13. Square rooting both sides, I get C equaling 3.6. Now let's start trying to figure out these angles. let's start with angle A. I am going to make use of tangent since I have the 2 and the 3 there. So the tangent of angle A equals opposite over adjacent. Okay? Now think back to last unit. How would I figure out what that angle measure is? So this is where inverse trig comes in. So if I want to find what A equals, I'm going to do the inverse of tangent and plug that into the calculator. So plugging all that into the calculator, we get A equaling 56.3 degrees. Now again, you can use another trig function to find angle B, or we can use the fact that angle A plus angle B plus angle C equals 180. And that tends to be the easiest. So we know that angle A is 56.3 degrees. We're trying to figure out angle B. Angle C is 90 degrees, and it all has to add up to 180. So subtracting everything over tells me that angle B has to be 33.7 degrees. Alright. Moving on. Last example here before we go to the next topic. Again, always start with setting up your triangle. A, B, C. Side A is 5. Side C is 13. And we don't know what B is. So if you recognize your special right triangles, you might already know what B is. But if you don't recognize that, let's go ahead and use the Pythagorean theorem. So A squared plus B squared equals C squared. So that means B squared would be 144. Square rooting, B would be 12. Now, let's find angle A first. Okay, this time I have 5 and 13. So I'm going to make use of sine. So sine of A equals opposite over hypotenuse. Again, inverse trig. So to find the angle, I'm going to do the inverse of sine of 5/13. Punch that into your calculator. Again, make sure you're in degree mode. And that gives me an angle measure of 22.6 degrees. So, angle A, we need to find angle B, and then adding in angle C, all adds up to 180. So angle B would have to be 67.4 degrees. Again, that's not the only way you could do it. Once we found that B was 12, we could have found the cosine of A equals 12/13. Or, let's say we wanted to start with angle B. We could have done the cosine of B equals 5/13. And so on and so on. So again, there's more than one way to do these. Alright, let's keep going. Now we're going to talk about the angle of elevation and the angle of depression. So this is where we're going to start looking at some word problems, and that's what makes this part tricky, is identifying what it's asking you to find and picking out the pieces that it gives you. But we'll look at that in a second. First off, let's define elevation versus depression and how those differ. So, angle of elevation is the acute angle measured from the horizontal line of sight up to an object. So if you think about a person standing, Right here is their horizontal line of sight. The angle of elevation is how far they have to look up into the sky to see an object. Okay, so this would be your angle of elevation. Okay. Angle of depression is a little bit trickier. So here we are again. Here is my line of sight, and it is the angle I have to look down. So that would be the angle of depression. I always like to use arrows to represent it. That way I know, okay, depression, down, elevation, up. And this image here on the right is a good representation of the difference. Usually if we're looking at an angle of depression, it's going to be something that's elevated looking down, and our angle of elevation is going to be something below, like a person standing at sea level looking up at a tower or something like that. And again, they have the arrows here. Depression, elevation. So let's look at some examples of some word problems. Now, you are going to have to draw a picture. We're not going to grade you on your artistic abilities. I am a terrible drawer, as you'll see here in a second. But we're not going to judge you on that, so don't worry. Looking at the first one here. A ship is just offshore of New York City. A sighting is taken on the Statue of Liberty, which is about 305 feet tall. The angle of elevation is 20 degrees. How far is the ship from the base of the statue? So, let's draw our picture first. We have our Statue of Liberty. She's got our little torch, head, crown. Okay. So here is my statue. Great picture, right? Now, off in the distance is our boat. So, Statue of Liberty stands at a height of 305 feet. So it tells us that in the problem. 305 feet. And there is our triangle. And it's asking us to find how far the ship is away from the base of the statue. So we're finding this x distance. And it tells me that my angle of elevation is 20 degrees. So the angle of elevation is from the ship looking up to the top of the statue. So here would be my angle of elevation, and that is 20 degrees. So we have an angle measure, a side length, and we need to find one more side length. So we're going to make use of our trig functions here. In this case, I don't know the hypotenuse, so that kind of rules out sine and cosine. So let's hope tangent can work for us. Tangent is opposite over adjacent, so that kind of works out perfect for us. So we have the tangent of 20 degrees equals opposite side, 305, over adjacent side. Now I'm going to have to do a little bit of algebra here to solve for x. To get the x out of the denominator, I'm going to multiply. Okay, that x cancels. So I have x times tangent of 20 degrees equals 305. Now to get x by itself, I'm going to divide that tangent of 20 degrees off to the other side. So x equals 305 divided by tangent of 20. Plug that into your calculator, and we get x equaling 838 feet, approximately. Okay. So that means that the boat is 838 feet away from the Statue of Liberty. All right. Top of a lighthouse, 210 feet high. Angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. And the lighthouse is built at sea level. So, lighthouse. Let's see how nice I can draw this. So there's my lighthouse. Not too shabby. Alright. So lighthouse, from the light down, stands 210 feet high. Okay, now it's asking us to find our x distance, and our boat is over here. Okay. Now, like I said, angle of depression is a little bit different. If you think about what the angle of depression is, we're using the light bulb as our eye line. So if we think about the light being our eye line, the angle of depression is going to be this. Okay, it's not going to give us the angle on the inside. It's going to give us the angle from our horizontal line of sight down to the hypotenuse. And that's why we always like to use the arrows to kind of identify. So we're going down from the horizontal line, and that was 27 degrees. But we can use that to identify this angle measure. Because what does the total have to be from here to here? 90 degrees, right? So if the angle of depression is 27 degrees, that means the angle on the inside is going to be 63 degrees. All right. Now, let's think about which trig function I'm going to use here. I have the 63 degrees, and again, I don't have the hypotenuse, so I want to think about tangent again. So the tangent of 63 degrees is opposite over adjacent. Okay, sometimes it helps to draw the arrows from your angle to make sure you're picking the right opposite side and the right adjacent side. So opposite of 63 degrees would be the x. So on this one, the x is going to be on top, which makes things a little bit easier. Adjacent side is 210. So to solve for x, I just have to multiply both sides by 210. So x equals 210, tangent 63 degrees. Type that in to your calculator, and we get 412.1 feet. All right. Couple more examples here. Alright, so Jack's mom is standing at the bottom of a slide waiting for Jack to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees and the vertical ladder to the top of the slide is 9 feet, how long is the slide? So let's draw our picture here. And we got our little guy here sliding down. So angle of elevation, so horizontal line up, that is 46 degrees. And it tells me that the vertical ladder is 9 feet. All right. And it's asking us this time how long the slide is. So this time, we're finding this hypotenuse. So let's think about the trig function we want to utilize. So here is my angle, okay? So we're using the 46 degrees, and I have the opposite side and the hypotenuse. So for this problem, I want to make use of sine. So the sine of 46 degrees equals opposite over hypotenuse. Multiply the h over, cancels. So h sine of 46 degrees equals 9. Divide the sine over. So h would equal, plugging all that in, we get 12.5 feet. Alright, last one here, real quick. A 50-meter vertical tower is braced with a cable. So tower the tower is 50 meters. And it's braced with a cable secured from the top of the tower, like so. And it says that it's tied down 30 meters from the base. So that means that this is 30 meters. What angle does the cable form with the vertical tower? So we're trying to find the angle that the cable forms with the tower. So would that be this angle or this angle? Cable and tower. That would have to be this angle right here. Okay, now if it said cable and the ground, that would be the bottom right angle. Alright, so we have our angle measure here. Let's call it A. So I have the opposite side and the adjacent side. I don't have a hypotenuse. So again, I want to think about tangent. So tangent of angle A equals opposite over adjacent. So 30 over 50. Again, to find the angle, I'm going to make use of inverse trig. So A equals tan inverse of 30 over 50, which is really just 3/5. Punch all that in, and we get an angle measure of approximately 31 degrees. Alright? So that is right triangle trig, basically. Now, the last thing we're going to talk about today real quick is area. Now, you guys are used to area of a triangle as 1/2 base times height. But we don't always know the base and the height. So when we have certain types of triangles, we have these different formulas. So if we have an SAS triangle, so side, angle in between, and then the other side, we can use one of these three, depending on the sides it gives us and the angle we have. If it's an SSS triangle, meaning it gives us all three sides, we can use this formula, where we make use of our side lengths here to find S. Alright? So let's look at some examples real quick. So the first one here, I have two side lengths and an angle measure. So I'm going to guess this is SAS, but we need to set up our triangle to make sure that that's the case. Now, these aren't always going to be right triangles, so don't assume that anymore. So A has a side length of 8, B has a side length of 6, and C is 30 degrees. So we have side, angle, side. So SAS, check. Now I have side A, side B, and angle C, so I'm going to make use of that first formula. A equals 1/2 A, B, sine C. Plugging everything in, A stands for area in this case, so the area equals 1/2 side A, side B, sine of 30 degrees. Now, if you think back to your unit circle, sine of 30 degrees is 1/2. So you could do it that way if you want it in this case. But doing our own multiplying, you can plug that right into your calculator. So the area is going to be 12. And again, no units, so we just say 12. Okay? Alright, you guys can try B on your own. If you want to go ahead and pause it and try it out, go for it. I'm going to put the answer up now, really quickly. 25. B is 4, C is 3. So area 1/2 BC sine A. So it's always going to be the two sides times the sine of whatever angle, and it's always going to be A, B, and C in some order. So in this case, B and C are the sides and the angle is A. If you look at the first problem, A and B were the sides and C was the angle. It's always going to work out that way. So my area, after I plug in everything, I would get 2.5. Alright, let's look at an SSS triangle. So, set up the triangle. A, B, C. I don't know any of the angle measures, but I know that side A is 4, B is 5, and C is 7. So in order to find the area of an SSS triangle, we first want to find what S equals. So if you look back, S has the formula 1/2 times A plus B plus C. 1/2 times 4 plus 5 plus 7. So S would equal 8. Okay. Now I can make use of my area formula. So area equals the square root of S times S minus A times S minus B times S minus C. Plugging everything in, we get 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. Doing all the subtracting and multiplying, we would have A equals the square root of 96. So the area of this triangle would equal 9.8. Alright, again, if you want to try D on your own real quick, go ahead and pause the video. I'm going to put the answer up now, really quickly. So here's my image. 3, 6, 8. So first find S, 1/2 times 3 plus 6 plus 8. So S would be 8.5. Now my area formula, I have 8.5 times 8.5 minus 3 times 8.5 minus 6 times 8.5 minus 8. Punching all that in and finding the square root, the area of this triangle would be 7.6. Alright, so that's it for the notes. There is one thing I wanted to show you real quick, and that has to deal with those of you who are going to look at the homework sheet. Okay, this is the sheet that you can print out and do separately. This is on the Delta Math, but I just wanted to help you set up problem number 9 from the homework sheet that's posted below this video. So it says a blimp suspended in the air 500 feet from the ground lies directly over a line from Soldier Field to Alder Planetarium on Lake Michigan. So let's set up that picture first. So here's my blimp. Not the best blimp. Okay. And it is 500 feet above the center. Well, not necessarily the center, but here's Soldier Field. And here is Alder Planetarium on Lake Michigan. Okay. So that forms this triangle. Now, it says that the angle of depression from the blimp to the stadium is 32 degrees. So again, angle of depression from the blimp. So I need that horizontal sight line. Okay, angle of depression would be down arrow, so it's going to give me that measurement. So angle of depression from the blimp to the stadium is 32 degrees. And the angle of depression from the blimp to the planetarium is 23 degrees. What is the distance between Soldier Field and Alder Planetarium? So it's asking us to find the total distance. I like to use x's because it's the x distance. So for this right triangle, this distance would be x1. And then this distance would be x2 for this right triangle. So you're basically going to make use of tangent twice and then add up your findings. And again, here's a little hint for those of you who are going to attempt this problem. Remember that these two have to add up to 90, and these two angles have to add up to 90. Okay? So that would be the tangent of whatever you found equals opposite over adjacent. So opposite over adjacent. So it would be x1 over 500. You would do the same thing over here. Tangent of whatever angle you found there. Opposite adjacent. Adjacent. x2 over 500. Do the problems, add up your 2, and that would give you the total distance. Okay? Alright, so that's it. Thank you.